Hi, this is Mrs. Blake, and today we're going to talk about mixed mole conversions, meaning our problems are not going to be separated out into categories. Instead, our problems are going to be different types of problems all kind of mixed together. The materials you need for this video are going to be a scientific calculator, a periodic table, and probably a piece of scratch paper so you can do the problems along with me. So we've been taking a look at mole conversions, and we can start with mass, we can start with moles, or we can convert to little tiny pieces that we refer to as particles in these problems. But these problems don't have one set starting place or one set ending place. Instead, they're mixed up. So let's take a look at some examples. So first step in any one of these calculations is to always make sure you read the entire problem. Determine the number of moles of carbon monoxide in 9.96 gram sample of the compound. And the most important thing I'm going to be looking for is units. Because if I look to my flow chart that's up here, I don't see 9.96 anywhere. But if I take a look at it, I'm going to see the unit mass in grams. I'm going to see moles, and I'm going to see particles. So these are unit conversions, and it is really important in your problem that you don't treat these as a math problem, that you treat these as a unit problem. So in my problem, I'm going to take a look and I'm going to find my number. My number is going to be 9.96, but the most important thing next to it is that little g, because that little g is going to give me direction on what to do with my problem. So I'm going to start with that 9.96, and the number in the problem is always your starting point. But the most important part is the G for two reasons. The first is I can take that grams and I can put that grams down on the bottom because in a unit conversion, I start with one unit and I want to change it to another, and that way it cancels out. And no matter what unit I start with, I can always take it to the bottom so I can cancel it out. The second thing that's important about that G is I can come up here and I can find that mass in grams is here, and that tells me my starting point. Well, this is a map, and this map tells me which direction to go and where to go. So if I have mass in grams, there's not anything to the left. I can only go to the right. And if I'm going to the right, the only thing I can go to is moles. Now that's important because that's my destination. So I can go from grams to moles, and moles is going to go here. And what is that as far as what am I using? That means I'm going to use my molar mass, which conveniently has units in grams per mole. In fact, if I take a look at my molar mass, the molar mass is going to be the mass in 1 mole of any substance. And that means I can put the number 1 in front of mole because molar mass is in 1 mole of any substance. So I'm going to go to my periodic table to find my molar mass. And I can find carbon, and I've got one piece of carbon. Its mass is going to be 12.01 according to my periodic table. I can have oxygen, and it's got one piece of oxygen, and my periodic table says it's 16.00 for oxygen. And so I'm going to take 1 times 12 plus 1 times 16, and I'm going to come out with 28.01, and this is grams in 1 mole. But I don't have to worry about do I multiply or do I divide here, because if I have 1 mole on top and it's a 1 that goes with mole, the only place I have left to put my 28.01 is going to be down here. Let's get a 1 here. And because my units grams are on the top and my units grams are on the bottom, they cancel out. And that leaves me the unit that's on top. I've converted the unit. That leaves me with moles. So I am no longer at mass. I am now at moles. Well, that may or may not be where I'm going to stop. So I've got to take a look at my problem, and my problem is going to say determine the number of moles. And if I'm at moles, which I am, all I need to do is calculate it out. Now it becomes a math problem. So convert your units first, and then the math becomes secondary. Now, this might look a little bit intimidating. These problems look a little weird, but I am always going to start with this 9.96 in my calculator. And if I start with 9.96, I'm always going to multiply by anything on the top, and I'm going to divide by anything on the bottom. So in my calculator, I am going to take 9.96. I'm going to take it times 1. I'm going to hit divided by 28.01, and I'm going to hit equals, and my calculator is going to come out with a big long decimal number, and I don't need all those decimal places. So I'm going to keep, let's just say I'm going to keep 3, and I'm going to say it's 0.3555. So I'm going to say 0.356, because 5 rounds up to 6, and this is going to be moles. And my question says determine the number of moles, and I have found the number of moles. Now, not every problem is going to start with grams. So it's going to be really important to pay attention to what are your units, because I can start anywhere. So when I go to the next problem, and I'm going to take a look at the next problem, it says how many molecules are in a 1.4 mole sample of dinitrogen tetroxide. So again, I have a number, 1.14, and I have a unit. And again, that is going to be what I'm going to start with in this problem. Except for this time, I'm going to start with moles. It doesn't matter what unit I start with. It doesn't matter how weird my number looks. I am always going to take this unit, and this unit goes on the bottom. And then I can take that unit, and I can go up to my flow chart to find out where I'm going. So it's not mass, but no, it is moles. So this time my starting place is going to be in moles. And if I start with moles, I do have a problem. Because if I start with moles, I can use Avogadro's number to get to particles, because to convert between particles and moles is Avogadro's number. Or I could use my molar mass, and I could go to grams. So I don't have enough information without going back to my problem to be able to solve this if I start with moles. So I'm going to go back to my problem, and I'm going to find out what my problem says. So my problem says how many molecules, and that's not grams. So if I'm taking a look at this problem, I'm going to go to molecules, and molecules must be one of the particles. And in this case, it is. So I'm not going to be using a molar mass, and I don't care about a molar mass, because this time I'm at moles, and I'm trying to go to molecules, which just happens because this is a covalent compound. No, you do not need your molar mass at all in this problem. So I have Avogadro's number here, and Avogadro's number says in 1 mole of anything, there are going to be 6.02 times 10 to the 23rd. Remember, Avogadro's number is very much like a dozen. I can have a dozen donuts. I can have a dozen cookies. I can have a dozen hamburgers. I don't know why I'm focused on food, but I am. So I can have a mole of anything. But in chemistry, we'll use the term atoms if we're talking about an element. We'll use the term molecules if we're talking about a covalent compound, which is what we're talking about in this problem. And we'll use the term formula units. The good news for you is that it doesn't matter what, it's always the same number, so the math towards it is always going to be exactly the same. So when I take a look at this, notice that Avogadro's number says in 1 mole. But wait, molar mass said it was in 1 mole. Both say it's in 1 mole. So in these problems, you can always put a 1 in front of your mole, because it's always going to be 1 mole. But this case, I'm going to look at Avogadro's number, and instead of adding up a molar mass, I'm going in the opposite direction, and I'm going to take it times 6.02 times 10 to the 23rd, and that's going to get me to the molecules. Now, really important when I abbreviate molecules is I do not abbreviate it as mole. So I use MC. Now, if I'm going to be multiplying or dividing by scientific notation, I need to be careful with how I put this in my calculator. So I'm still going to start with this 1.4. I am still going to multiply what's on top. I am still going to divide by what's on the bottom. But when I punch this number into my calculator, I am going to put in 1.4. I am going to hit times. But there is a button to be used on your calculator that is going to replace the times and the 10. And on some calculators, it is going to be an EE. And on some calculators, it's going to be an EXP. If you use the Google calculator, it's going to be the EXP. And how do I put that in my calculator? I'm going to put in 6.02, and I'm going to use that EXP button. And it is going to replace the times, the 10, and the only thing I need left is the 23. So I'm going to put 1.40 times 6.02 EXP 23, and I'm going to divide by 1 before I hit equals. So 1.4, and I'm going to take it to times 6.02 EE or EXP and only put in the power of 23, and I'm going to divide by 1, and my calculator is going to come out with, well, there's a decimal number here. You just multiplied by a billion trillion, and if I'm multiplying by that, don't stop with the decimal number. I'm always going to have something times 10, and this is going to be, in this case, 23. Now, on some calculators, this will come out as 8.4, oh, it would say 28, and it'll have this E here before I have a 23. And it means exactly the same as what I just wrote out. That E is times 10, and the 23 would become my power. Now, since my units moles were on top and moles were on the bottom, moles canceled. That left me with molecules. So I'm just going to write my abbreviation MC, which I'm going to use to represent molecules. And there's the answer to that problem. So let's take a look at the next problem. And when I'm taking a look at the next problem, I'm looking for the number. So this is 2.13 times 10 to the 24th formula units of copper to chloride. So this is going to be 2.13. It is going to be times 10 to the 24th. This is formula units, and I abbreviate formula units with an F and a UN for units, so fun. And I don't care what my number is, I don't care what my unit is. I'm going to put it on the bottom so it can cancels out. And I'm going to go up to my chart. And this time, I am not going to be starting with moles. This time, I'm going to be starting with formula units. Well, if I start with formula units, I really don't have an option. I have to use Avogadro's number, and it's going to get me to moles. I don't care what my problem's trying to get me to. I am going to use Avogadro's number, and it's going to get me to moles, which goes on top. Well, there's always a 1 in front of mole, and that must mean the 6.02 times 10 to the 23rd is going to go on the bottom. Well, that's going to cause my formula units to cancel, and that's going to leave me with moles. But my question isn't asking me for moles. My question is asking me for mass, and that means I have one more step that I need to do in this problem. So now I've converted, and now I'm at moles. But now I need to take one more step, and I need to get to mass, and that's going to be with my molar mass. So basically, this problem is combining the first part and the second problem all together into the third problem. So I need one more line, and this unit is going to go to the bottom. And if it's moles, I can sneak a 1 in front of it, and this is going to be a molar mass, which is going to be 63.55 plus 2 times 35.45, so I'm going to get 70.90. And this is grams. So I'm going to punch these numbers in my calculator quick and come up with 476. Watch your units with these conversions.